Okay, we're going to be looking at some questions on quadratic equations so that we can prepare for the quiz. These are the 8 questions that were assigned to you on the review sheet. So let's start with number 1. So we've got to factor these expressions. So the first one I can see is a difference of squares. I can see that there's no common factor because the x squared is only made up out of x's, while the 81 does not have any x's in it. These two terms have got nothing in common, so there's no common factor. The second thing I'll look for then is to see if it can be expressed as a difference of two terms that are being squared. Sure enough it can, because 81 is 9 squared, so let's ignore the squares for just a moment, and we get our first factor, x minus 9, and x plus 9. And we can always check our answer by FOILing this out. So if I do my first terms, x squared, my outer terms, positive 9x, my inner terms, negative 9x, so you see that the positive 9x and the inner term, negative 9x, will cancel out. And then we've got negative 9 times positive 9, which gives you your negative 81. So that's the correct factorization. We checked our work and it worked. The second one, however, is we're going to use a different technique. Although there's a common factor in the first two, I would ideally like to take a common factor out of everything. And this one's only made up out of x's, but there are no x's in this last term, so there is no common factor. It's clearly not a difference of squares. A difference of squares occurs when you have two terms. This one has got 3 terms, and so it must be a trinomial. So let's use the trinomial method. Turns out that this is going to be the easy trinomial method because it's got a 1 in front of the x squared. And so we simply need to look for two numbers that will multiply to give negative 28. I'm just going to write this out to the side. Two numbers that multiply to give negative 28, but they will add to give positive 3. Now if they multiply to give negative, that must mean that one of them is positive and the other one is negative. Turns out that the positive one must be the dominant one, because when you add our positive number with our negative number, we're left with a positive result. So the positive was dominant by 3. What two numbers multiply to give 28, where one of them is 3 bigger than the other? I think you'll see that those numbers are 7 and 4, and we know that the dominant number, the 7, is the positive number, while the other number must be negative 4. To give a total, a product of negative 28. And so I can just immediately factor to an x positive 7 and an x negative 4. Again, let's just FOIL this out to check that it worked. X times x is x squared. The outer terms gives you negative 4x. The inner terms gives you plus 7x. So if you think the negative 4x plus 7x, that gives you the 3x that we needed. And lastly, 7 times negative 4 is negative 28. I've checked my work with expansion. I got the original expression. I must be correct. Now part C wants us to use the answers from parts A and B to solve these equations. I already have got a new expression for x squared minus 81. By factoring it, I was able to rewrite it as a sum and a difference, because it was a difference of squares. Now I can use the zero product property, which says that if a times b is equal to 0, then either the first factor is 0 or the second factor is 0. So in this case, either x plus 9 will equal 0 or x minus 9 will equal 0. And that gives you your two solutions of x is equal to positive or negative 9. There's actually another way that we could have solved this equation. We could have put the 81 on the other side at the very beginning and said that x squared is equal to 81. And then when we square root both sides, we have to include the plus minus, and that gives us the plus or minus 9. However, it did say use your answers from part A, and so we had to use the factoring technique. Even though another option was available to us, it wasn't in this particular question. Part D, let's replace the quadratic expression with its factorized form. This means that either x plus 7 is equal to 0 or x minus 4 is equal to 0. And if we solve, we'll find that x is equal to negative 7 or x is equal to positive 4. And I should just probably check both of these answers to make sure that they do work. So if x is negative 7, that gives me 49. 3 times negative 7 is negative 21. So I've got 49 minus 21 minus 28. Yes, that does indeed give me 0. What happens when x is 4? I've got 4 squared is 16, plus 3 times 4, that's 12. 16 plus 12 is 28. 28 minus 28 does give us 0. They're both correct. I am done. Let's move on to question number 2. We're being asked to solve this equation by completing the square. Completing the square, we're going to focus in on the x squared term and the x term. More specifically, I want to look at this number right here, this positive 12. If I take that number, positive 12, and I divide it by 2, I get 6. So when I factor it, it'll become, alright, the plus comes down, it'll become an x plus 6 all squared. But that's a little bit too quick, I think, so I'm going to go back a step. And before I get there, I want to see what am I adding to both sides in order to complete the square. The thing that you add to both sides is going to be that number squared. So we'll take half of the 12, which is 6. We'll square it, that's 36. And that's what I'm going to add to both sides of the equation. And the left-hand side, as I showed you a moment ago, we know will factor to half of the 12, which is positive 6, x plus 6 all squared. And on the right-hand side, I've got a 43. Perfect. I've now isolated a perfect square, so let's take the positive negative square root of both sides. That will give you then that x plus 6 is equal to plus or minus root 43, which sadly doesn't simplify because 43 is not a perfect square. I don't want to use my calculator to give some decimal approximations. It's always better to leave answers as exact numbers wherever possible. If I bring the positive 6 to the other sides of the equation to isolate x, I'll discover then that x is equal to negative 6 plus or minus the square root of 43. And if you wanted, I guess you could express these as separate answers, although it's not necessary. You could say it's negative 6 plus square root of 43, and the other solution in this quadratic equation, remembering that almost all quadratic equations will give you two solutions, your other one is negative 6 minus root 43. Let's move on to question number 3. We've been given this function here, f of x. We've been given this function here, g of x. I want to find out when are these two functions equal to one another. Alright, so I'm starting with f of x equals g of x. Let's substitute in their corresponding values. So I've got x squared plus 3x minus 24, and g of x is equal to 5x plus 11. Now there's a couple of different ways that I could solve this. The question has not specified what method to use. So a good method might be to use my calculator. So let me go to y equals, and as my y1, I'm going to put in my left-hand side of the equation. You can actually solve any equation in the world using this technique, but I'm going to use the calculator here. X squared plus 3x minus 24. And as my right-hand side, I'm going to say 5x plus 11. And I'll graph. There's my parabola, that's my first one, and there's my line. Alright, we can't quite see the points of intersection. It appears like one of them might happen down here somewhere, while the other one, maybe this line will eventually meet the parabola up here somewhere. Let's increase the window so I can see things a little bit better. And so really I need to look lower down on the graph. I'm going to make my y min say negative 25 to make sure that comes into focus. And I'll make my y max something like 50, I don't know. And let's regraph and see if I can see something better. There's my parabola, and there's my line, and look, now we can see the 2 points of intersection right here and right here. The x values at these two places are going to be the x values where my functions are equal to one another, meaning that they are intersecting one another. To find out the x values of these two intersection points where the functions are equal, we'll say second, trace, to go into the calculate menu. We'll come down to option 5, which is intersect. It says, what's the first curve? Well, yes, that is my first curve, so I'll press enter. What's the second curve? Yes, my 5x plus 11 is the second curve. And it wants me to guess. So I could either move my cursor all the way there to the first point that I'm trying to find the intersection of. That's one way of doing it. I could also simply type in a number. I'll do that when I'm looking for my other intersection. Let's just move the cursor nice and close. It doesn't have to be exactly on top. And I'll press enter. Tells me that the x value, we're only looking for the x value here in this question, the x value for the intersection is -5. And so we'd say, alright, x is equal to -5. Let's repeat the process to find the other intersection point. Second, trace, intersect. Our first curve, yes. Second curve, yes. This time, instead of the tedious procedure of me scrolling all the way over there, I'm just going to enter a number for x that I believe is close to my solution. 1, 2, 3, 4, 5, 6, 7, maybe 8. Let's see if my guess of 8 is correct. Well, I was close, but not quite. My intersection point, my x value, where the functions are equal, is actually 7. So x is equal to 7. And those are my two solutions. In terms of showing your work for this problem, if you use a graphing method, we should just draw a very quick sketch of this graph. And so you can see that we've got a parabola that's a little bit over to the left side, and then we've got a line that goes through like that and creates those two different intersection points. And that will probably be enough to show to an examiner what method you've used in order to solve this. I also wanted to show you another way that you could have solved this problem, again using the calculator. If I brought all of these terms over to the same sides of the equation, I get x squared plus 3x minus 5x would yield a -2x. And -24 minus 11, as it comes across, will become a -35. Now some of you might already be able to look at this and see that this will factor. Two numbers that multiply to give -35, well, one of them must be positive and the other one must be negative if they give a negative product. And when I add them together, I got a -2, implying that the negative number is dominant over the positive by just 2. So can you think of a positive and a negative number that are 2 units apart and multiply to give 35? Obviously those numbers are -7 and +5. And so it would factor to x minus 7, x plus 5 equals 0. And if you isolated each of those factors using the zero product property like I did up here, you would again find these two solutions. But I said that I would show you how to do this using another technique on the calculator. And that means going into my apps. If I press apps, you shouldn't have all of these apps, of course. I'm going to go down to the P, Polysimilt 2. And in Polysimilt 2, which you should have on your calculator, we want to use polyroot finder. We want to find the roots of this polynomial. Now you need to have a 0 on one side of the equation for polyroot finder to work. Alright, so let's do our order of 2, yes, because it's a second degree equation, so we'll say next. It wants us to enter the coefficient of the x squared first, then the coefficient of the x, lastly the constant term. And so our coefficient of the x squared is 1. Our coefficient of the a1 term, the coefficient of x, is -2. And the coefficient of the third term is -35. And then I'll press the solve button, and immediately it tells us that my two solutions are +7 and -5, exactly what I had already found. Okay, I'm going to pause now, and you can continue watching these solutions on the next part of these review videos.